Good morning, everyone. Thank you for joining us on this morning's webinar on configuring the OCS-IO. We'll do our usual. We'll just go straight into it. And if you have any questions, feel free to ask any point and we'll get to them at the end.
Hello and welcome to today's webinar. Today we're going to be looking at configuring OCS-IO. Let's get started. Let's look at our agenda for today. We'll start by looking at the general configuration process for OCS-IO. We'll look at simple single-base systems and a bit more complex multi-base systems. We'll look at the tools that are built into the OCS system menu that might be handy if you're using OCS-IO, and we'll look at the individual configuration options for the IO points that are built into the OCS-IO. There will be demonstrations throughout, and we'll finish with a Q&A session. Firstly, we'll look at general I/O configuration for OCS-IO, starting with single-base systems. Configuration is performed from Cscape, and it can be done completely offline without equipment present. However, if you do have your equipment and you can set up Cscape, your OCS, and your OCS-IO to all be connected and online, then the bases can be auto-populated in Cscape, which will save some time. Once the base has been added and auto-populated, we just have to fill in some remaining details, and we'll look at those now. So there will be a default base name that is suggested, which is just used for documentation purposes. It'll suggest a network ID, which you can change if you like. It will also prompt you to set a status variable, which we would recommend as it will allow you to see diagnostic information. For OCS-IO, you'll need to assign that. If you're using register-based I/O, it'll be a series of 15 consecutive %OR type registers. If you're using variable-based ladder or IEC-based programming, then you're going to set up an integer type or array with a dimension of 15. Another thing we need to do is to set the starting addresses for the digital inputs, the digital outputs, the analog inputs, and the analog outputs. It will suggest a communications timeout, the default being 1 second, which is the amount of time that the OCS-IO base is willing to wait for communication from an OCS. If it doesn't hear from an OCS over that time, it will go into a safe state. So those are the details that need to be filled in. A UUID is a very detailed 192-bit serial number, which is usually represented by 6 consecutive 32-bit hex numbers. The purpose of the UUID is for there to be a unique serial number for every OCS-IO base that is shipped. This is a feature of the microprocessor that we're using, and it's designed by the microprocessor manufacturer. And we're using this unique serial number so that the OCS can keep track of the fact that you have multiple bases that are different. So the UUID is how the two bases are differentiated from each other. Multiple base systems are very similar to single base systems. The only real difference is that with a multi-base system, if you want to use auto-population, then you will bring up one base at a time, starting with the base that you want to be considered the first base, or usually base 1. So you'll get your Cscape talking to your OCS controller. It will be connected to the first base, and you'll effectively add your base and auto-populate that base. Once that's done, you'll add the next base and auto-populate that one too. When you're done adding your last base, then you go back and fill in those details. So the only difference is that you bring up one base at a time in the order in which you want them to be numbered. Now we'll look at some of the system and the new tools that are available in the OCS if you're using OCS-IO. So we'll look at what the system menu tools look like for the OCS that have support for OCS-IO. So for those units, you're going to go to the system menu, then you're going to select View I/O slots. After you select that, the next menu will have OCS-IO configuration as an option. On the OCS-IO configuration screen, you're going to be able to see all the bases that are configured with their name, their network ID, their status if they're enabled. We can see the UUID listed there, and then you'll see all the modules that are connected to that base. And you'll see all those details even if you have a multiple base system. And in the case of a multiple base system, if you ever need to replace one of the bases, you will use the system menu to do the replacement, and we'll look at that later. Now we'll look at some of the I/O configuration options that are available for the different types of I/O points that are available with the OCS-IO to get an understanding of what the options are. Doing the configuration on a module by module basis is very straightforward, and we'll start with a digital I/O module. So this isn't any one module, but any OCS-IO module, or the I/O built into the CNX base, for instance, that is a digital in nature, whether it's an input or an output. So 99% of the time, the default configuration for an OCS-IO digital I/O point is going to be just fine. So you can change filtering and the hold state, the things that you're not going to change very frequently. Now the one thing you might change occasionally would be if you ever need to configure the I/O points for negative logic instead of positive logic. Then you would go into the configuration for that particular module and change the input configuration from positive logic to negative logic, but that's the exception. 99% of other cases we just leave at default. Now we'll look at the configuration options on the ADU100, which is our Universal Analog Input module. At the top, there's a digital filter, which is a setting between 0 and 7 that can be used as a compromise between stability and response time. At the bottom, there's an update time option that has a default of 500 milliseconds that can be set so that the ADU100 module knows how often it needs to broadcast a new set of values for the analog input channels. 500 milliseconds is the default. You might want to bring that down to 50 or 25 milliseconds in most applications. That's the frequency at which the channels will be updated by the ADU module through the base to the OCS. So still looking at the ADU100, you have your choices on a channel by channel basis for the different types of sensor or signal that you want to be compatible with, as well as the data range. If it's a traditional analog input data range, the highest resolution will be 0 to 32,000, but there are other options for convenience. If we're looking at temperature like a thermocouple or RTD, you can choose between degrees Fahrenheit and degrees Celsius, and the readings will come back in 10th degree increments. Now we'll look at the 4-channel analog output module, which is very similar to the analog input module in terms of configuration. We configure the channel type, the data range, and the only extra thing is something called a halt state. So when the OCS goes into stop mode or stops communicating with the OCS-I/O base, you have your choice there of what needs to happen to the output in that scenario. The 4-channel analog output OCS-I/O module, unlike a lot of I/O systems, supports -10 volt to +10 volts. Now we look at the built-in I/O, which is in the CNX base itself. There are 6 I/O points. We'll start with the one universal analog input point that we have built into the CNX. It configures similarly to the ADU100's universal analog inputs. You select data type, data range, and your filter constant. The CNX has 2 flexible inputs that can be either digital or analog points. If you use those points in digital mode and it's channel by channel selectable, you get to choose your voltage range between 24, 12, or 5, and even a custom range, and of course positive or negative logic. If you're using those flexible inputs in analog mode, you select between voltage and current and you select your data range. Now we'll look at the output channels. There's 1 channel of analog output and 2 solid state outputs. For the analog output, we can choose the signal type and the data range, as well as what we want the output to do when the controller goes into stop mode. Digitally, it's like any other digital output with OCS-I/O. The only thing to really configure is if you want to do something different, from a hold last state standpoint when the controller goes into stop mode. Usually you don't just leave it at default. Now we'll start the series of demonstrations on doing actual configurations, starting off with a single base system and then moving to multiple base systems. So here we have an OCS-I/O rack which is connected electrically to the OCS through CAN cable here, which is actually a modified patch cable. There's a terminating resistor installed on the second RJ port here on the OCS base, and the base is not powered up yet, so now we'll power it up. You can see the flashing lights as it powers up, so we have the controller in run and we press this button and we go to the I/O menu in the system menu. That's the shortcut we created. We'll press enter again to look at the OCS-I/O configuration, and there are no OCS-I/O bases configured. Now we'll go to Cscape and into hardware configuration. Then we go to the CAN tab where the OCS-I/O is physically installed. Then we press add, we'll go to the OCS-I/O tab and select the CNX base. Here we'll press auto populate because we are in line with the OCS and the OCS-I/O is powered up and physically connected to the OCS. So it asks if we want to auto populate the I/O base and we press yes. And it comes back with an OCS-I/O base that it found with this UUID, and it's asking if we want to assign this net ID to its respective bases, and we say yes. So it checks all the modules, it found them all, and it tells us the auto-populate is complete. So we select OK, and there we have our OCS-I/O base, which is a base with 3 modules. But we're still not talking. As you can see, there are still flashing lights on the base. So the automatic portion of the configuration is now complete. The reason we can't do it all at once is because there are some things we do have to tell the base manually in terms of how we want to configure. So we're going to start with the I/O base and we're going to double click here. So we're going to rename the base, but you could leave it as base 1 as well if you like. We'll call it OCSIO_1. Network ID of 1 is perfectly fine. Then we have previously created a status register variable that we will assign here, and it's 15 consecutive letters, and we referenced the first element of the array. Then from this point forward, we need to assign the digital in and digital out, analog in and analog out real-world I/O registers, where we want all the OCS-I/O in this base to start. In this case, we're going to have them start at %I65, %Q65, AI65, and %AQ65. We do that because we know those addresses are well away from where the built-in I/O is mapped. Because we're using variable-based advanced ladder, we need to reference one of the variables built into the project. By default, there are some real-world I/O arrays we can use here. So we're going to use I64 because arrays are always 0-based. So %I65 references I64. Always the index is one less than the actual 1-based memory address. So we'll fill in the rest of these, and we need to make sure to put them in a location where they won't conflict with the built-in I/O. So we also need to configure any of the I/O that isn't just digital I/O, so let's go back to the base. When we double click on the base this time, we go to the Onboard I/O tab and configure the onboard I/O the way we want it. For universal analog in, we'll have a 4 to 20 mA input with a range of 0 to 32,000. We'll assign a bit of filtering for stability at the cost of some response time. On the two flexible inputs, we will enable channel 1 and make it a digital input of 24 volts, and enable channel 2 and we'll make it an analog input of 0 to 10 volts. This is a 12-bit analog in, but we'll still choose a range of 0 to 32,000. And then we'll enable the analog output for 4 to 20 mA with a range of 0 to 32,000 in order to have maximum resolution available, although this is a 12-bit analog out. And on the whole state, when that analog output is turned off, we want it to go to its minimum value. Now we have two digital I/O modules. Usually there's nothing you must configure with digital I/O unless you want to go with negative logic inputs, because the default input filtering and not holding any outputs to last state is generally what we want. But if we do want to change to negative logic inputs, we would change that here, but for now there's nothing we want to change from the defaults. On the ADU100 we'll set it up for a J-type thermocouple on all 4 channels and leave it at the default of degrees Celsius. For update method, we want to update faster than every half second, so we'll put it to every 100 milliseconds. This is the frequency at which this module is going to be distributing new readings for each of those 4 channels. Again, we have the ability to use filtering, and we'll set it to a value of 3 to achieve some additional stability. So the configuration is done, and now we'll download this configuration to the OCS. Because we're using Ethernet to communicate to the OCS, it'll give a warning to be careful that you don't accidentally overwrite your IP address to the wrong value and lose communications halfway through, but that won't be a problem here. Now we see that the lights are all solid on the I/O base, so that's up and running. Now we'll go to the system menu on the OCS and see if we see anything for the OCS-I/O populated there. This shortcut takes us to the I/O configuration screen, and if we press enter, we'll go to the OCS-I/O screen. And if we press enter again, it'll show the populated modules along with the UUID that is there for the base that was populated. So that is the straightforward approach for configuring a single rack of OCS-I/O. For the next demonstration, we'll see how you can swap out a CNX base in the field without opening Cscape. So firstly, we'll power the system down. Then we'll pop the power connector from the existing base, disconnect the communication cables and save the terminating resistor. Then we'll remove the existing base, and we'll add a new base. So we'll reconnect the OCS cable and the terminating resistor and reconnect the power cable to the new base, and then we'll power it up. So there are flashing lights and it's not booted yet. Now it's complete and the lights stop flashing as it automatically recovers. So it was able to automatically find the new base, wipe out the UUID and its memory table of the OCS and start up again. So that's all there is to swapping out a CNX base. For the next demonstration, we're going to configure 2 OCS-I/O bases automatically from Cscape. We'll start with both bases physically installed and powered up, but only the first base is connected. So there's the cable to the OCS and the terminating resistor on the first base. The second base is not connected to the CScan network. So we'll go to Cscape, back to I/O configuration on the CAN tab, add OCS-I/O tab, select CNX 116 and auto-populate all. It asks if we want to auto-populate and that it will overwrite any previous populations. It finds the first base because that's the only one connected. We say yes, so it's going to auto-populate complete. So it found the first one and assigned it as ID number 1, the reason being we want this base here to be number 1, so that's why we only connected the first base to the network. Now we're ready to physically connect to the second base, so we move the terminating resistor and then connect the cable that connects the two bases to each other. This is now the new end of the network. Now we'll go back to Cscape and we'll press Add Base, and again we're adding an OCS-I/O to CNX base. And again we press the Auto-Populate All button, so it's finding and auto-populating this new base. Now it's found both of the bases, base 1 and base 2 are the default names, and we can go in and double click and configure all the details for each of these two bases, the same as for a single base. Now we'll look at what happens if we need to swap out a base in a multi-base system. So we have a multi-base system set up here which is already up and going. We can look at the OCS-I/O configuration and we can see we have 2 bases. We have base 1 that has a UUID that starts with a 001A, and we have a base 2 that has a UUID that starts with 2A, and we're going to swap one of those out. So let's assume this one needs to be swapped out. So we'll power it down, even though it's not fully necessary to do that. Then we'll pull the plugs here, and we'll disconnect the network and pop this module here. And then we'll get the new one in. Then we'll connect the network and connect the power connector, and once we've done that, we'll power it up again. With a single base, after a few extra seconds of boot up time, everything came up and booted when we had to swap out the CNX unit in the main base. So the first rack is working, fully up and running, but the second rack is still flashing. So we'll give it a few more seconds and see if it automatically starts working or not. So if it doesn't recover automatically, we'll see what we can do to get the system back up and running without opening Cscape. So we'll go to the system menu and we have the shortcut here. We'll go to the OCS-IO configuration and go to rack 2 because that's the one that's faulted and the one we want to replace. Press enter. Now we're going to go down to UUID assigned and press enter again. It says that it found a new UUID and we press enter and then it is assigned. We have that new UUID going now. And if you look here, we are fully up and running. So again, this is another example where you can swap out a CNX base without having to get the software out to get things back up and running again. In this case, when you have multiple bases, you do have to use the system menu that's built into the OCS to get the new base assigned and up and running. So all in all, OCS-IO configuration is a straightforward process. If Cscape is online with your OCS controller and the OCS-IO, then the IO base can be auto-populated in Cscape, which can save you a bit of time. If you need to replace a base or an IO module in the field for any reason, both of those tasks can be done without any Cscape intervention, even on a multiple base system. So that concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, so that is the last of our OCS-IO videos. We are back into a UDFE video next Thursday. I'm not seeing any questions in on that, so it must be very straightforward for everyone. Okay, thank you all for joining us this morning. We'll see you next week.